Hello, math champions. In this video, we're going to learn about the proof of one more circle theorem called given here that angle at the center of the circle is twice the angle of the circumference. As we discussed in the other videos, what is the reason to learn the proofs is that our reasoning ability will improve. Okay. And also we can use these theorems, use these conclusions in solving various different situations where we deal with geometrical figures, especially the circle. Okay, so now this theorem statement says angle at the center of the circle is twice the angle at the circumference. So the first step is to draw the diagram. So we have a circle, we know, and the theorem statement itself says we need a center. So yeah, we want to take a center, and it says next the angle at the center. So I'm going to draw two radius. Okay, two radius. And this AB is an arc. AB, the curved part is called as an arc. The center, we name it as O. Okay. So we have an angle at the center. And that, which is that angle? This angle is this much. The angle AOB. That's what we're talking about. And it says angle at the circumference. That means we need one more angle. The same arc is subtending. Okay. The same arc is subtending this angle uh, on the circumference. So we are having this. Let's give a name to this as C, maybe. Okay. Now this is done. So they're saying this angle AOB is twice the angle ACB. That is what we're going to show. We have to prove. Okay. That is what is the thing. So as the first step goes, there are three steps usually, or especially in proving theorems, the four steps. Three steps are first we have to find out what is given to us so that we can use that information in our proof. The second one is what is the thing that we have to prove. And the third one is the proof itself. But however, sometimes for proving things, we need to have some extra things that we are going to draw apart from what are the things given in the theorem statement. The theorem statement has a center, has a circle, has an angle, has a circumference. All of these things we have drawn. But this information is not sufficient for us to prove. So we are going to use one more construction. So these are the four steps. Let's start with what is given to us. What is given to us is O is the center. O is center is given to us. What else? Is there something else that we can figure out? OA is equal to OB. Why? Because these both are radii. We know that. These are the things we can decipher from the figure itself, what is given to us itself. AC and AB are chords. We cannot say anything much about it. Okay, that's all we know. Okay, what is to prove? We have to prove that angle AOB is twice, two times the angle ACB. This is what we have to prove. Now, before we go to the proof, we need some construction. As we know, if we have two radii, then what happens? It becomes easy for us to use the two radii because they are going to form a isosceles triangle. Correct? So, we're going to draw another thing here and let us extend this. Not meet the this one. However, we are extending this one. What do we know? What do we know? That OC also becomes a radius. Let's name this extended point as D, let's say. Okay. So this is our construction. So construction is join OC, which is equal to OA, which is radii, and extend it to D. Extend it to D. That same line is extending. That's the construction we have. Now coming to our proof, the fourth step, correct? Now fourth step is proof. What I'm going to do is, because this line OD is cutting this, we don't know whether it's bisecting or not, we don't know that. However, what I'm going to do is, let angle AOD is equal to X degree. That means this much is X degree. And let ADOB is equal to Y degree. Okay, Y degree. Okay, so we are having this, we are going to assume these things so that it will help us to draw various different, do many other things. Now, what happens if you see, because of this construction, we have got two triangles. This side is one triangle, this side is another triangle. Okay, so we're going to take one of the triangles. Okay, in triangle AOC, what is happening? This angle X, if you see, this angle is outside this triangle and it has extended from this one of the sides, right? So this angle AOD is an exterior angle. Angle AOD is equal to angle CAO plus angle ACO. Correct? How do we know? What is the reason for this? Exterior angle is equal to sum of interior opposite angles inside a triangle. Right? That means to say, if I add this and this, I will get this one. Correct? If I add this and this, I'm going to get this one. Okay. So what happens? I know this is equal to this plus this. But we know, this angle CAO is equal to angle ACO. Why? Because this is an isosceles triangle. Which one? Isosceles triangle ACO. Why? Because we know OA is equal to OC. It's radius. So the angles here are equal. Now comparing these two equations, what do we come to know? The first equation, first one and the second one. What happens? It is equal, they are saying, and summation is x, right? Summation is x degree. That means this will be half and this will be half. Therefore, we can say angle ACO is equal to x by 2. In the similar way, similarly, if you compare to do this for the y side also, if this is y, then this will be y by 2 and this will be y by 2. Similarly, what we know that BCO will be x by 2, y by 2. When I'm going to take this other triangle, which triangle? If I'm going to take this triangle, this is going to be y by 2. Okay, good. We got these two things. Now, what is it that we wanted to show? We wanted to show that AOB, correct? We wanted to show this, right? To prove. How can we do that now? Angle AOB is nothing but x plus y. Now, x plus y, okay? That is x plus y. Fine. Then what happens? Now, let's say angle ACB. Angle ACB is equal to x by 2 plus y by 2, which is nothing but x plus y by 2. Comparing this and this, I can say that angle AOB is twice the angle ACB. I can say comparing 1 and 2. Right? Because this is x plus y by 2. This is x plus y. So obviously this is half of it. So this is how we have proved it. Hence, we have proved that the angle at the center is twice the angle at the circumference. I hope you have understood how we go about solving and or proving this theorem. See, this is one of the ways. You can do many ways as you want to do. Okay. But for every statement, we are giving the reason. That is what is very important. And more important than that is the application. You use this conclusion in solving various different geometrical problems. Okay. Until the next video, see you. Bye bye.